Right answer for this question would be any two people are connected in a friendship network with a small path length. So a the first option, any two people are friends in the world, this is not always true. Like there are people whom you don't know. The- Most people are isolated in a friendship network. That also is not true. So there are local communities in a friendship network, and it usually forms a connected component. So isolation is not a question in friendship network, and friendship network representing the world is small. So this is also not correct, fully correct. So the right answer is option C. Coming to question number 2. So, which of the following graph can represent the friendship network of a neighborhood? So, remember, in a neighborhood, the people who are in a neighborhood, people live close by. So, as a result, due to homophily, most of them would be friends. So, if you see option C and D, it forms isolated components. As you can see in option C, M is isolated and there are three clusters. Again in D, J and K, J, K, L and M are isolated and there is one cluster in between. Such things usually do not occur in a friendship network because it means that in such a network, let's say consider the network in C, it means that no one is connected to M, no one knows about M, or M does not know anyone in the neighborhood. So this is not usually the case because if you stay in a neighborhood due to homophily, everyone or nearly knows everyone. So we are left with two connected graphs A and B. Now, which among A and B would represent a friendship network? Now, as you can see, homophily is observed in both A and B. So, uh, but it is more strongly observed in A. So in A, the nodes are much well connected than compared to node B. Also in node B, as you can see, the number of weak ties are very less. So there are only A's connected to B and C together. Otherwise, they form a chain kind of structure. So this is homophily is observed, but there is absence of weak ties. Also, the diameter of the graph is large. So in usually the diameter of a friendship network is on an average 6. So taking all this into consideration, the best option that represent the friendship network is A. So it does not mean that B cannot be a friendship network, but on average, A represents best is the best option among these four. Uh, Coming to question number 3. So in question number 3, Rahul has 6 friends. Each of his friends also has 6 other unique friends and so on. How many people can Rahul reach within 3 hops? So let us draw this diagram. So you have Rahul over here. Rahul. And Rahul has 6 friends. 3, 6. So mm, there are 6 friends, and each of these 6 have 6 more friends. So here it's 36, and if you go on to the next level, it is 216. So what they're asking is how many people can Rahul reach within 3 hops. So from starting from Rahul, you can reach his 6 friends in 1 hop. You can reach the 36 friends of his 6 friends in 2 hops, and 216 friends of his 36 friend of friends in 3 hops. So the total number of friends that can be reached is 6 plus 36 plus 216 which comes out to 258. So the right answer for this question is option B. Okay, let us move on to the next question. Which of the following is the reason for the grid in friendship network? So basically, grid-like structure is observed in a friendship network because of closeness. So uh, nodes that are close become that are close become friends, like in a neighborhood that you become friends with your neighbors. So that is what I meant by closeness, the physical proximity. Prox. So this is related to homophily. So you have three options: homophily, weak ties, and rich get richer phenomenon. But the grid-like structure is seen due to the physical proximity, which is other words is homophily. So the right answer for this question would be only one. Okay. So someone has asked for a doubt in question number 2. So I'll repeat question number 2 once more. So they are asking there are four types of graphs. So which of them represent the friendship network in a neighborhood? So in a neighborhood, it if you see the four graphs, first let us observe C and D. You see, C has this is a disconnected graph and so is D. So which means that if you look at C, that M does not know about this cluster A, B, C, D, E or J, K, L, and no one in the neighborhood also knows about M. So which is usually not the case. So in a neighborhood, most people are likely to know each other, and same applies for D as well. Now we are left with A and B. Now if you see A and B, in A and B, homophily is observed that that nodes that are close by are connected to each other. But if you take a closer look at B, what happens is that there is an absence of weak ties. So only homophily is observed. So B is friends with D, D is friends with E. So they are friends with their immediate neighbors. But there is hardly a presence of a friendship between two distant, relatively distant nodes. Like so here homophily, but no weak ties. And from the Watt-Strogatz model, we know that a friendship network has two components: weak ties and homophily. And here, if you take a closer look at A, both homophily and weak tie can be seen. Homophily because A is connected to B, B to C, C to D. So neighboring physically close nodes are connected to each other. And also there are connections between relatively distant nodes such as B and M or from M and F. So such presence of such weak ties make it closer to a friendship network. So A is the best answer for this question. Okay. I hope it's clear. So let us carry on with our discussion. So we finished question 4. Now let us move on to question number 5. In question number 5, Ram creates a graph on network X where he makes a 2D lattice and connects nodes that are adjacent to each other through an edge. So basically, he's creating the homophily component of the friendship network. After doing, he randomly rewires a few of the edges with some probability, which is 0.02 over here. What should be the average path length between any two nodes in the graph? So this follows the Watt-Strogatz model. Rogats model. So in such a case, the average path length is around 6 and is independent of probability. So with whatever probability he rewires, as long as he rewires, and as long as he's creating this weak ties and creating the homophily based lattice, so the graph will be uh, following the Watt-Strogatz model. And in such a graph, it turns out that the average path length is almost always around 6. So the right answer is option C, 6. Coming to question number 6, the edges which are not in your neighborhood and connect you to friends from distance regions present. So A, strong ties, homophily, weak ties, and social influence. So these are basically weak ties. So in weak ties, the nodes. So if A and B, there's a weak tie between A and B, it means that um, there are very few mutual friends. There are very few mutual friends. Weak tie. So mutual friends arises. So A's most of the friends will be from A's region. B's most of the friend will be from B's region, and A and B are connected. So therefore, it is a weak tie. So option C is the right answer. Coming to question number 7. In a friendship network, suppose Ram wants to reach Andrew through the shortest path between them. Ram has 4 friends: Raman, Raghav, George, Ashraf. Andrew's house, Andrew's distance from Raman, Raghav, George, and Ashraf is 10, 4, 6, and 9 units respectively. If we choose the path to Andrew using the decentralized search, when the path to Andrew goes through, so the path to Andrew goes through which of his immediate friend of Ram. So let us draw the picture. So you have Ram over here, and you have Andrew over here. Now in between you have his other friends. So let us write Raman, Raghav, George, and Ashraf. Now Ram is friends with all 4 of them, and Raman is Ram knows that Raman's distance to Andrew is, we don't know whether Raman and Andrew are friends. So let me draw it with a dotted line, a dashed line. So we don't know whether Raman is directly connected to Andrew or Raghav is directly connected to Andrew, but what we know is the distance. So Raman's distance to Andrew's place is 10, Raghav's is 4, George is 6, and Ashraf is 9. So it appears that Raghav is closest to Andrew, and by myopic search, Ram gives it to Raghav, and who has a highest chance of giving it to Andrew. So the right answer is Raghav. So because Raghav is closest, has the closest distance to Andrew. So whether this is optimal or not is not sure, but it's definitely what the decentralized search or the myopic search does. Coming to question number 8, in a friendship graph, the distance between Ram and Andrew is 20. Again, so you have Ram over here and Andrew over here. and the distance between them is 20 units. If we create edges according to the Watt-Strogatz model, given k equal to 2, what is the probability of them being friends? So probability is given by 1 over d to the power k. So basically 1 over 20 to the power 2, which is 1 over 400, that's equal to 0.0025. So option C is the right answer. Coming to question number 9, which of the following options is false in a small world effect? So you have four options. Every two people are connected with a path. So this is according to the small world effect. It's a connected world. So every two people, so between any two random people that you pick, so there exists a path. So this every two people is connected with a path. This is a this is true. So let me write it with true. The average path length between any two people is 6. Again, this is true from Milgram's experiment and the Watt-Strogatz model. It turns out to be true. People only form friendship within their neighborhood. So this implies homophily only. Homophily only. But in a small world effect, we have both homophily plus weak ties. So option C, there is something wrong. So option C is not correct. So this is false. And if we look at option D, we can attribute this phenomenon to weak ties and homophily. Yes, this is again true. So the right answer for this question is option C, where this is the only false option related to a small world effect. Coming to question number 10, which of the following observation is correct according to Milgram's experiment? So you have four options. Letter reach the destination within a small number of hops. Letter didn't reach the destination. Letter reached the destination with a large number of hops, and letter reached the destination in one hop. So in the right answer is option A, and it was seen that average number of hops was around 6. So letter it didn't happen that letter didn't reach the destination, and also it didn't take a large within a large number of hops. It might have been for a large number of hops for us for a few exceptional cases, but on an average it was 6, which is considered to be small, and letter reached the destination in one hop, so that was also not true. The right answer is option A. So now you can ask any question related to week 11 assignments before we proceed on to week 12. So you can ask by unmuting yourself or typing in the chat box.
Sir, question number 6, I have a small doubt, sir. The probability question, sir. Average
Okay,
path.
wait. Yeah. Question
Not,
number
not
6.
this, sir. Not this, sir. Average path length on some was there, no, sir. That's some, sir.
Yeah, in 5, this one.
1 second, sir. This question came in last assignment question, sir. It was asked us for millions of networks, sir, and probability value was wrong, sir. But for that also the value was 6 only, sir.
Yeah.
If probability value change also same value only will come, sir.
Yeah, that is the thing about this model. So it will, if you rewire with whatever probability, so as long it is not 0, so and not 1, so if you rewire, you see the it average is around 6. So what will happen? The variance might change in the distribution, but the mean will be nearly around 6 if you play with the probability.
Okay, sir.
Yeah. So this probability value has no importance actually in a question. So in any question in such a case where homophily is occurring, where he says that he makes a 2D lattice and the adjacent nodes are connected. So this is homophily, and if he rewires, that is formation of weak ties. So if he combines these two components, then it follows the Watt-Strogatz model, and the average path length would be around 6. So the probability value mainly determines what's the variance in the path lengths that would be occurring. So a small probability would create a large number of variance in the path lengths because of the diameter of the network could be large, but other than that, the probability value has no effect on the mean of it, which is the average path length. So any more questions, you can write in the chat box as well. Yes. Okay. So if people do not have a doubt, I think we can move on to week 12, and then you can ask questions at the end as well. So let us go on to week